All right, how we doing, everybody? Doing good. All right, we're streaming it. Might as well. I think it's worthy of a stream. And then let me just pull this guy up. So let me see. Let's pull up this handsome gentleman, Dr. Morris. If only you can just be here. He's here in spirit, everyone. 360D. Boom. Ooh, everyone watching the YouTube videos. Everyone saw that review. How was that? How was the exam? That was last week, right? How was it? Was it a fair exam? Did I prepare you guys? That's good. That's good. Yeah. Just you have the allocated time. Do your best. Was there calculators? Yeah. Of course, you don't really need it. It's just variables. But cheat sheet. Right. Not too hard. Hopefully, everyone passes. Or I think you guys should be fine. Um, but anyways, we'll see. Okay. I'll see you guys in 361. Anyways, comp 7. Is that what we're talking about today? Let me see. What are we supposed to talk about today? Discrete time. And then, yeah, he's not doing continuous time. Okay, so today is 422. Okay, we'll talk about this. See how chat doing. Chat sleeping. Anyways. Signals and systems. So you guys know state space equations. He talked about it. Yes? What do you guys think about them? Okay? Oh. And that was yesterday? Or today? So then, but he posts a video, right? Did he post it? When does he usually post it? Did he? No. Anyways, thanks for giving me the confidence, everybody. But let's see. Guess who made this assignment? Me. Yeah, feels good. Anyways, guys like my little thing? So, you're going to go over this. Here's your solution. No one's going to listen to me when I say that for 5 seconds. Here's your other solution, 1 second solution. Controls toolbox, Equal length function is going to be great in this class because it makes sure everything is like, 1 to 1, zn, z minus 1, dot, 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 dot. Controls toolbox. System function. Yes, because a discrete rational transfer function can then be defined as this. Everyone's solution on the exam? Or the homework? Okay, someone's not going to listen to me, okay? A factored system representation. Cute. Okay, I didn't know you can do that. So maybe Dr. Morris did change this assignment. State space can be defined by this. State space system analysis. Oh, this is good. You kick your box, right? Kick the box. Everyone likes kicking boxes. So what's this right here, sys? Right? System, which is from this. Everyone's going to do that. Easy assignment. And then we don't have to, convolve. Actually, well, never mind. You will. See the step response? So it's not a kick the box. We turn on the box, flick the switch, right? See what your system does when it turns on from 0 to VDD, right? RC circuits, right? Let's see. LSIM. It basically throws a random signal at your system, right? Or not random signal. It's a user-defined input signal. So for example, what's his name? Xn is the length of this input signal. Okay. So basically, depending on how long your signal is, okay, that's the end that's going to be spit out, okay? So if I have a system, right, A, B, C, D, and I throw like a step response, right? Everyone understanding what's going on? Oh, wow. Did I give you this answer? No, I didn't. Oh, this is an answer. Oh, great. You guys have so much help. How do you convolve two systems? Just do this multiplication. Oh yeah, that's why state space equations are strong. They're great. They're powerful little systems. But I think I'm losing everybody. But let's go back. Yeah, let's see. Chat. How we doing? One viewer. Cool. Let's see. Do I know? Yeah, I don't even know how this thing works. Whatever. So, state space equations. Basically, all this time you've been doing what do you call it? Previous inputs and current inputs. So like you have a delay, and you're like, yeah, I got some information, whatnot. Cool. So it's like what do you call it? Y n plus I don't know. Stable. Whatever. Right? Is equal to y or x of n plus x of n minus 1. You know what? I'm going to do something funny. B0, B1, then A1. Can you guys see that? Is that okay? I don't know. I don't like it. A1, B0, B1. Okay, remember those coefficients and how we built these block diagrams? You guys remember block diagrams? Let's build a direct form 2. Let me see. Let me just go back to the assignment. Okay. Something's wrong here. Let me just look at something, okay? Let me just look at something. Something's wrong. I'll probably tell him to edit this. Let's see. What did I do for my students the last semester? No, not that one. Controls toolbox. Oh gosh. How were you able to you guys were able to generate state space equations with direct form 1? Yes? Oh, well, you guys did you? Direct form 2. Okay. Okay, this is good. State space equations for DF1 and no. This is not going to work. Okay. Let's stop thinking about the answers. Let's start thinking about what we know, okay? Because that's my job, is to bring you guys that confidence. Direct form 1, what do we do? Feed forward, feed back. I got to tell you guys, okay? I love it when I visualize things like this. Feed forward, right? Feed back. Really simple stuff, right? Remember that? So feed forward is these guys, right? Pretty chill. Factory A, factory F, whatever we want to call it. Here's my X, right? And then let me just go down here. Delay, right? D1. Here's B0, just existing. And let's put a plus sign right here. And then let's put a B1, right? Cool. Everyone's getting what's going on. Then this is going to be our output. I'm going to call it C of n, or Cn, x, n. Cool. Everyone understand what's going on? Feed forward, feed back. Purple. Okay, feedback. What do we do for feedback? We have our input, right? And now we got to feed it back, right? So here's our output, y. Everyone understanding? Yes, no, maybe? Please let me know. Yes?
Don't we use the z to the -1
Delays? Yeah. That's right there. You can either do D for delay, or you can do Z -1, right? Same thing. Everyone understand what's going on? These are both delays. Cool. Any other questions? Simple, right? Okay. We need to delay the output by 1, right? To get this guy right here, right? So I'm going to delay it. Okay. And here's my dilemma. A1. minus A1. And why did Dave do that? So you see this output right here, right? Right, remember that? Solve for y, remember? Yn is gonna equal, does anyone bother if I do Cn, which is equal to these guys right here? Cool? But then you see this delay right here, this output, right? It has to go on the other side of the equation. Everyone understanding what I'm trying to do? Because the output sees a negative A1 when I add it like this in this feedback. Cool? Any questions? So I'm trying to figure this out because I don't know if this is what I think I'm gonna have to talk to him because I don't know. I don't want you guys doing it like this. So there's delays, okay? You have previous outputs, you have delays, and you have current inputs, right? X of n, y of n, stuff like that, okay? With state space equations, let me see, I'll put another piece of paper. We care about the future, okay? We're gonna be controls engineers, all right? Controls engineers are funny because they don't like delays. They don't like this, okay? They're like, ew, delays. So what they do, so if I were to do like, okay, DSP engineer, right? Which is yn plus a1 yn minus 1 is equal to b0xn plus b1xn minus 1, right? But yeah, the controls engineers are like, ew. So let's do a change of variable where n minus 1, we don't like that delay. Gotta kill that delay, replace it with, I don't know, k. Right? So that means k is equal to, what's his name? Wait, hold up. N is equal to k plus 1. Right? So now let's do that change of variable. Let's grab the orange marker. So now this yn, right? We got to replace that, right? With yk plus 1, right? Cool. And then, what's his name? Plus a1yk is equal to b0xk plus 1, right? And plus b1x, okay, right? And now you can see it's in the future because controls people want to predict the future, okay? They want to know what is my system going to do in the future. So so controls engineer. Okay, sounds cool. So because controls people only care about current state or current input. So current input. Let me see. Remember current inputs and next states. Next states. Current states. Maybe I'm blanking out. Give me a second. Boom. Let's look at my review. Right here. Current states and current inputs. So did I do this one right? Anyway, I don't think I did. Current input, current state. Maybe I'm confusing you guys with that. But what I'm trying to say is, I don't know if we can. Oh, sorry, I didn't show you guys that. There you go. Current input, current state. And what I'm trying to do is, here's our current input, right? Here's our current output. But we have this, and this is what I'm trying to show you guys. Let me see. Can everyone agree that this xn right here, right, turns to xn minus 1 at this node right there, right? And then, well, it just gets multiplied, but I don't like this. I'm going to show you guys the formal way, okay? I'm going to talk to Dr. Morris. Remember those direct form 2 blocks, right? How do you do the direct form 2? Feed back, right? Into a feed forward. Remember that? Easy. So how are we going to do the feedback? Right? Start there, okay? And then this is where the waterfall goes. No, it goes backwards. So plus right here, feedback, because the water has to go backwards. Like that. That's a wire. Then it goes backwards. Minus A1, right? You guys see that? And then I think that's it. Yeah, that's it. Okay. D. Cool. And then here's B0. And this is your plus Y. Then there we go. B1. Everyone seeing what we're trying to do? Direct form 2. Cool. So now this is where I can finally teach. What's this node right here? Huh? Yeah, WN, right? But let me call it state. It's gonna have a voltage, right? I don't know the voltage, right? It's gonna be something. It's gonna be a state. So I'm gonna call this Q1, state 1. Okay, is that cool with everybody? And I'm gonna do Qn plus 1. Everyone's seeing what I'm trying to do, and the arrows go this way. Waterfall goes like this, right? Everyone's seeing what's going on. Cool. Everyone following? When this state goes through this filter or this delay, what's the state over there? What's the voltage? Right? Cool. Everyone's following? So I'm gonna tell you something. In the end, what we want is we want to define any, what do you call it? Predict. We want to predict things, okay? Predict, what do you call it? Future with y of n and q n plus 1, okay? So we want the output and we want next state. Right? Because that would be nice to know the future. Imagine if like you just took an exam, right? And imagine you can see the future and like, oh, based on my current input and my current state, did I pass the class? Yeah, so basically we want to predict the future only with what you know and what you're throwing at the box. Okay? Is everyone following? So current, like the present, and what information? Memory, right? So I kicked the box, I did something, I'm walking, I'm talking, and what else does exist? Noise, thermal, etc. Okay? Everyone following what I'm trying to do? That's what state spaces are for. They're really, really cool. Q1, right? This guy right here. This is a future, right? All right, that's the future. And this right here is an output. Everyone seeing what's going on? Cool. And then this right here, I'm gonna draw it right here. This is our current input. Cool. Everyone following what's going on, and then this right here is our current state. So we want this and we want these two, okay? So we need to solve all our equations. Well, this and this, right? We want the futures and we want the outputs based on these guys, okay? So I'm gonna turn up the heat, okay? I want everyone to follow this. I want everyone to go home and be like, man, this is great. Okay, I don't think I'm gonna talk about MATLAB, okay? That's due next week, right? Let's do a second. Should I do second order? Nah, let's do second order, okay? So let me see, yn plus yn minus 1 a1 plus a2 yn minus 2 is equal to b0 xn plus b1 xn minus 1 plus b2 xn minus 2, right? Should I do the cheat code? Oh, maybe I should have just copy pasted this to another paper, but so I just want to see how fast I can draw a block diagram. I choked. I'm blank. Let me see. Okay, there we go. And then there's everyone's like, whoa, what's going on? How was that for magic tricks? Oh. Where? Oh. Cool. D minus A1 minus A2 B0 B1 B2. Ooh. Arrows, 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 arrows. X, Y. How'd I do? You guys gonna do that for your exam? It's okay. How did I do that? You know, years of practice. Okay. You're not gonna get good overnight. You have to practice engineering. Okay. Practice your math problems. All right. So, I want everyone to do this on their final exam. Okay. Q1. Q1. Everyone seeing what's going on? Okay. So we're gonna do the following. N plus 1, okay? I'm just going to define this node, this voltage as N plus, okay, Q1, N plus 1. Everyone seeing what's going on? So now I'm going to do something funnier, okay? I have to use colors, okay? I don't want to lose anyone. This is where I'm going to lose a lot of people, okay? This is memory, right? Also memory. When you have a memory cell like this, okay, there's always going to be a next state and a current state, okay? You have something in memory, right? Capacitor or a flip-flop or a flip-flop, D flip-flops, yeah, right? Or no, not D flip-flops, D registers, DQ, next states? I don't remember. CP stuff. You can do CP stuff with this. Clock, 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 right? So anyways, we're going to clock our circuit every second, every sampling time, all right? So what you're going to do on your exam is you have a state here, and it's going to get delayed, okay? So I'm going to do the following. Q1N, okay? Right there, okay? On your exam. Or I'm just telling you what I believe. Right? We have another memory cell, right? I'm going to put this as Q2, right? Right? When it goes through the delay, what happens? Cool? What did I say for state spaces? We need to solve for the future. We need to solve for output based on current inputs and current states, right? I wish I used the same color, but it's okay. So, let's digest this, okay? See this Q1 right there? That's a future, right? That's a future input or future state. Yes? Yes? Cool. So what I'm going to do, oh yeah, don't forget the plus. Q1N plus 1. All right, that's a future, right? Future state, Q1, state 1 or something, S1. Everyone understanding what's going on? What's that equal to? Come on. XN, X of N, right? Or, yeah, this right here. And then, ooh, here's a tricky problem. This minus A1, right? We have Q1 here, but we also have Q2 and plus 1 right there, right? So what should we do? Come on. What's the signal here? Choose. Yeah, because it's a current state, right? Right? So minus A1 Q1, right? Q1N, right? Make sense? Q2? Oh no, we want to solve for this with our current state and current inputs, okay? So here's this minus A2, right? And then Q2N. Cool? Everyone? Yes. Okay. I want to drill a routine on you. This is what I want everyone to force to memorize. Okay. Q1, Q2, Q3, Q4, Q5. Okay. Fun enough, I did a little cheat where I already did the calculation right here. What's the value here that I calculated? Well, this is our calculation. It's just a delay. Okay. So if you wanted to see the other variant of this, for completeness, Q2N, right? Right, you see this Q2 right here, right? Multiplied by this, but if you did the following, A2, A1, Q2N plus 1, right? The next state is equal to the next state 1 or Q1. The future Q1 is going to equal to the future of Q2. I don't want that. Okay, we want to predict the future. Let's see, let me do it again. Future. Predict the future with our current input and current state. Everyone's seeing what I'm trying to do? And then here's another current state right there. Okay, so what happens with this guy? We gotta make it current. Okay, so what's Q2? Okay, Q2N plus 1. Everyone understand what Q2N plus 1 is going to equal? What's this equal to? Right? So we're going to replace all these with this. So guess what? We already did the right answer. Congratulations. Put that on your final exam. Okay? Everyone following what I'm trying to do? I'm getting head nods. I'm losing you. It's okay. Final project season. It's okay. What about... So we solved for this one. This is good. It's all based on currents. Or Q2, Q1. Actually, wait a second. Oh, gosh. Future. Right? The future is equal to... Right? We're predicting our future with our current state. Is there a current input? No, right? Because we're only using this node right here. Waterfall goes down here. Everyone following what I'm trying to do? Does this make sense? Am I losing anybody? I'm getting the... Okay, what's up? Okay, let's do it. Let's do it slowly. Okay, so let's start going back to the fundamentals. In the end, you're going to do the following matrix. I'm going to go right into the matrix. Okay. Let me think. No, I think I need the answer for this one, or not the answer, but just there we go. Q. Let me just write this for me. Okay, Q. QN. Do I need that? Q. Yeah. N plus 1. Give me a second. Just give me a second. A A Q N plus B X of N. And then this is Y N is equal to Qn plus 1. Give me a second. Is the output a matrix? Hold up. C Q of N plus B X of N. Okay, cool. Boom, magic. Everyone see what's going on? So your goal as an engineer is to solve for this. Okay? That's your goal. Why? It's for the MATLABs. Okay? Are you understanding that? Are you understanding what the mission is? The mission is to solve for these A, B, C, Ds, and then what's this right here? Next state. And current output. This is going to be on the final exam, by the way, okay? I'm going to use another color. Okay, I love colors. What's this right here? QN, right? And it's a current state. Right? Everyone seeing what's going on? What's this right here? Are you seeing the mission now? We need to find the A, B, C, Ds of our current state and current inputs, okay? To solve for the future, the next states and the current outputs. Because this one right here is what we publish in MATLAB, okay? The output, that's what we want. So if he's telling you to find a step response, solve for Y using A, B, C, D, okay? He's going to ask you that. This is going to be on the final exam, both analog and digital, okay? Everyone can do this. Yes? Oh, anyways, let me see, because digital isn't too bad. Analog is a little more tricky, but I'll show you a trick for that, but I'm not going to do that this class. Next week I will do that, okay? So, let me see. If I have a second order equation, okay, I'm going to start grilling you all. Order, right? I'm going to have two delays, right? Two delays. Everyone understanding what I'm saying? Two memory cells. So what does that mean? If I have two memory cells, I'm going to have two states, two capacitors. So I'm going to have two QN, right? Or two QN states. Or let me show you. Q1 n plus 1, right? Q2 n plus 1, right? Right? I'm going to have two states. What about my output? I just have one output. Okay, one output. And then two states. Yes, and delays, okay? So for analog, it's the order. So if it is a second order equation, you're gonna have two states, right? So RC, you have two RC filters in series, signals and systems, electronics. Cool, like those buzzwords. For second order difference equation, you're gonna have two of these guys, okay? Memorize it. So if he throws you and he might do this, third order equation and just set up the A, B, C, D, are you gonna do that? Where he's gonna make B1 equal to 0, make it tricky? Yeah, be prepared, okay? I don't know what he's gonna do, okay? He might take off points for that too. What's the size of this in terms of matrix? We got one column, right? Two rows, one column. Right? What about this one? 1x1. Everyone seeing what's going on? So that means our results, like the equations here have to match these guys, okay? Everyone understand what's going on? So we need 2 by 1. So A, we we have two states, right? Let me show you. Q n, Q1n, Q2n, right? Everyone seen that? Yes, yes. So, let me see, Q1. Let me just do a big plus sign. What's the dimension of x right here? Just 1 by 1, right? X and right there. Okay. So for B, right? This is a 1 by 1 right here. Okay, I need to use another marker. I'm gonna lose somebody. 1x1 right there, right? But we need 2 by 1, right? We need a 2 by 1 thing because this one right here. Or okay, let me see. Whatever. B. See B0, B1. No, because that's not the right thing. Let me see. B11, B22. Because I don't want to say it like that. B. Yeah, let me just do it like this. B11, B. How does Dr. Stever do it? Because I don't want to confuse you guys. B1, B2, A1. Okay, we're doing that. Okay. B1, B2. Okay, this is not the gains. Not the gains, okay? Someone's gonna do this and someone's gonna not have a fun time on their exam, okay? This is not a gain. This is just the matrix. This is the values that are in the matrices, okay? Everyone see what I'm trying to do? And this right here is a 2 by 1. So that means these two together, when they multiply, result in a 2 by 1, right? Cool? For this guy right here, okay, it's going to be A11, row column, 1, 2, A2, 1, A2, 2, okay? Everyone seeing what's going on? 2 by 2. And this right here is a 2 by 1, 2 rows, 1 column. Then the output, okay, we have a 1 by 1, right? So that means our output has to be 1 by 1, okay? So C, okay, let's write our answer. Q1n, Q2n, right? What is this right here? 2 by 1, right? So that means, what does C have to be? The first number has to start with 1, right? And then we have to make sure the inner numbers are 2, 2, so they match. C1, C2. Cool? Everyone getting what's going on? And then this guy right here. It's going to be x of n, but this one's easy. Just do D. And that's your big general answer, okay? But this is not a direct form 1 nor a direct form 2. Or not direct form. Oh gosh, this is why I got to talk to Dr. Morris. He didn't teach you guys transpose direct form 2? Transpose direct form 2. Transpose direct, you know it, right? But did Dr. Morris do it? No, he didn't. All right, I'm gonna have a talk with them. So, because this assignment you can't do direct form 1, you can only do direct form 2 and transpose direct form 2. Why? Because you have memory. But let me see. No, we can't do that. No, I'll research it, and because I don't think it's possible. Okay. Now we got to solve for the A's, B's, C's, and D's. Okay. Everyone seeing what's going on? Is this page 4? So let's go over a second order equation. Okay. Or do you want me to do third? Third? No, just or second. Because I think second's easier. Okay, plus, let me see, this is x, feed back, and then this right here is B0, feed forward, okay, so then I have to put a delay here. Wait, Okay, everyone's seeing the feedback? Cool. And then this is B1, B2, plus waterfall, 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 and then it rises back up. Everyone's seeing what's going on, okay? So, this is a node right here, right? Right? So what I want everyone to do, okay? This is something I have to force into everyone's mind, okay? Q1n plus 1. Okay, I don't know how he's teaching it. Is he doing Q2? You let me know, okay? Q1, because it's the first order, right? Because if I got rid of this, of course it's going to be Q1, okay? This is that wire. Everyone understood what's going on? This right here is going to be Q2. Everyone's going to do this on the exam, okay? Page 5. We got to solve for this node, right? We already have a label, V out, V in, I don't know, W square, fish. It's just a label. This label, what's it equal to? Right? Are we seeing what's going on? But do you see the problem right here? What's this label right here? Well, it could, but we don't have a third order, okay? But do you see a hint right here, this Q2n plus 1? These are forced labels that I put. You're going to force this label, okay? So this one is going to be Q2n, and that's our goal right there, okay? Is that cool with everybody? So what's the easiest equation you can... Because we want to solve for this. Solve for this and solve. Okay? Everyone seeing what's going on? Let me see. I'm thinking about how I'm trying to teach it to you. Because let me see. How do we solve for this one right here? What do we know? What information do we know? Yes? Let me just use an orange marker, okay? Okay? Because of this right here, it's filtering in, right? We want to solve for this. What is this equal to? That's an easy answer, okay? You're going to memorize this, okay? So, let me just do another piece of paper, okay? Let's create a chart. We're going to do a Easter egg hunt, okay? We're going to solve for all these values, okay? So I'm going to do it right here. Here's my Easter egg hunt. Okay? Q1 n plus 1, Q2 n plus 1, and then yn, okay? And Q1 n, Q2 n, and plus. Cool? I'm setting our playground, okay? Q1n, Q2n, X. This is our playground, okay? DF2, right? Let's hunt for some Easter eggs, okay? So, engineer, what do we know? We got to solve for this guy, right? What's it equal to? It's equal to one of these dudes, right? So what am I going to do in my thing, okay? Give me a second. Everyone knows how to use matrices, right? So position 1, position 2. This is a position 1, this is position 2, right? Then this is 1, 2, okay, let me see. For this one, 1, 2, okay, dot, 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 okay? So when I'm doing this, okay, I start here, okay? The way it's going to work for this equation, it's going to equal this times this. Okay, everyone see what I'm trying to do? Let me just make it more clear. Okay, if I made this a star, right? The star equation is going to equal the multiplication of these two plus the multiplication of these two right there, okay? So dot, dot, right? Bom, ba, right? So, well, this is Q2. Let me use this blue marker right here. Another star. Okay, is that a good marker? No. Let's see. Do I have hot pink? Hot pink. Okay. I don't know. Let me do check mark. Okay, is that cool? So for this guy, right, we have to do the following: bang, bang, boom, boom. Right? Everyone understanding what's going on? Right? So for Q2, right, it's equal to one of these guys, right? So which position does this go in? So we have this Q2, right? This guy and this, see what I'm trying to do? So we have a 1 right here, right? Everyone seeing what I'm trying to do? Right? Do we have a Q2 in there? Do we have a Q2 in this equation right here? Yes, no? No. It's just equal to itself, like this right there. 0. Am I losing you guys? Come on, let me know. Okay? I'm trying to fill out these squares, all right? Are we understanding what the mission is? Okay? So, we want to solve for this. They're blank. We got to solve for them, okay? We're going to find them, okay? Very quickly. Here it is, right? What's this equal to? I'll write it. Let me write it over here. Q1n plus 1. What's this equal to? Right? The input. And then it's equal to this right here. Minus A1 Q1n. Right? Minus A2 Q2n. Right? Everyone seeing what's going on? Let's go to our Easter egg hunt. Okay? We just solve for it, right? Is that it? Is that it? Okay. Boom, boom, boom. Cool. So, how do we fill out our chart? Q1, Qn, right? We have a input right there, right? You see the input? What's in front of that input? 1, right? So that means for this equation, right? There's this is position 1, this is position 2 for the B, right? The B. So for this one, it's this, and that's it. It's just this. See how it's kind of 1-to-1 like this? I can't do, you see for this one right here, I was able to do bop, 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 right? For this one, it's just nothing much. Everyone see what I'm trying to do? So for Q1, right? Let me see. I just have 1. Cool? Easy. But I have these two states right here, right? I have this right here. Okay. So Q1 n plus 1 has a state at Q1, right? So I'm gonna do the dance, right? So here's Q1, right? What does that have? So I'm gonna put minus A1, right? Then I'm gonna do this. Boom. Q2 minus A2. We solve for A. Woo! Now, hey, wait a second. We have this right here. Did Q2 have an input? It doesn't have an input. Oh, it has a current state, right? But it doesn't have an input. It doesn't rely on X. So what does that mean? Congratulations, you solved for your A and B. Are you understanding what's going on? Did everyone understand what's going on? I don't want to write on this one. Okay. All right, here's the big cheese. What's the output equal to? Okay. The output is equal to whatever this guy is right here, right? Ooh, this is going to be tough. This is going to be tough, y'all. It's going to equal to B0. Do I want to write it on here? I don't. Let's write it here. Q1n plus 1. Okay? Plus this right here, right? So plus B1 Q1n, right? Cool? Plus B2 Q2n, right? Now, who sees the problem? We don't want that there, right? What was Q1 equal to? Pain. So we can replace this into this. Are you following what I'm trying to do? Okay, thank you, thank you. So I'm gonna get this blue marker right here. So what am I gonna do? B0, big bracket, X, N, right? Minus A1, Q1N, minus A2, Q2N, right? Right? And now I can just fill out the rest of my equation. Plus B1 Q1N plus B2 Q2N. Everyone understanding what I'm trying to do? I'm going to simplify this, okay? Everyone's following what I'm trying to do? I have one input right there, right? Okay, I'm gonna write it right here. YN. I'll just leave the N. Okay. Let's use more markers. I love visualizations. Green. Okay, there we go. Here's Q1, right? Here's another Q1, right? Combine like terms. So we have B0 and this guy, this minus A1 right there, right? Okay, I'm gonna do Q1, right? Okay, I'm just gonna write that there, okay? Q1 and what does it have? It has this B1 right there, right? And then, there's a negative there, right? So minus, someone's going to see the trick. B0, A1. Right? Cool? And now I'm going to use, where's my other marker? Give me a second. There you go. I'm going to use this magenta, or this dark one. This right here and this right here, right? Plus Q2, right? So we have this B2, right? Minus B0 and A2, right? We're all seeing what's going on? And then what's the final thing? We have this final term right there, right? The black marker. Plus B0 X. All right. Last thing before we finish, okay? Current states, right? What does the output see? What's Q1 right here? You guys like colors? B1 minus B0 A1, right? That's first position. And then Q2 right here, right? So it sees this guy. B2 minus B0 A2. Right? Second position. Cool? Bang, bang, bang. Cool? And what does the output see relative to the input? And that's your answer to the final exam. Any questions? This right here, solve for the A and B. That's your final exam. And then for this guy right here, you solve for C and D. Everyone's going to get a good grade on this final exam. And if he throws a third order, you know how to do it. Any questions? Chat, how we doing? No one's in chat. Have a good day.